recording now. Go.
Great. Thank you. Thanks, Mahmoud. Thanks a lot for having me and giving me the chance to talk about this very particular subject. So you were not sure about how long this talk is going to last. I'm not quite sure either. So I have three topics I want to talk about. Let's say I go over the first two. Since this is quite informal, we see where we are, and if we still have time, because I don't want to talk for more than 45 minutes. This way we can have a couple of minutes in the end to have some kind of discussion about whatever thing you find to be most interesting, if it's the case. So disclaimer from my part, this is not an academic talk at all. I'm not in any way a professional philosopher or a professional physicist. I just happen to teach physics and philosophy, and I know a thing or two about what made me do this, and I'm going to try to share this with you today, not in a personal way, of course, but I think these 3 or 4 topics that I'm going to talk about, they are quite interested. I was quite interested in them, and they are quite interesting in themselves. And they are well known. Everyone talks about the philosophy of time, the philosophy of cosmology, the Big Bang, etc. So the biggest part of my talk is to try to tell you what these things are not. So it's going to be kind of a much more negative talk than a positive one. So there you go. Physics meets philosophy. You couldn't think of a more catchy title for my talk. And you got to give it to me. I had to write quantum somewhere, right? Because apparently it's the thing that sells the most in physics today. No, physics is not only about quantum mechanics. Yes, physics was very, very philosophically interesting way before the quantum revolution of the 20th century. And hopefully that's what I'm gonna make you see today. So practically in a sentence, I'm gonna try to explain 3 lessons that that physics, theoretical physics, can teach us about 3 philosophical debates that are actually quite old. So it's not practically, or it's not philosophy of physics that I'm going to be talking about per se. It's more about how 20th century physics reshaped, in a way, philosophical debates that dates back, most of them to the pre-Socratics. And the 3 lessons are going to revolve around the concepts of time, of substance, and of the universe, because the concept of universe itself has evolved a lot through the years, from mythology until modern cosmology. So before we start, I'm going to talk just a little bit about this not so friendly relationship between science and physics in particular, and philosophy, metaphysics in particular. And I stress that it's traditional metaphysics that I'm interested in the sense that we're going to be talking about debates that date back from quite some time. So how does modern physics illuminate? How does it reshape these philosophical or metaphysical debates? But before I can talk about this, you all probably know that the relationship in academia, in popular culture, quite everywhere, the relationship between philosophy and science is very, very shaky. So it wasn't always the case. It is very shaky today, but that wasn't always the case. my slides are not nothing fancy, and they're mostly excerpts and quotes I got from physicists and philosophers through the years. So the problem is twofold. The origin of the problem of this weird relationship between philosophy of science is twofold, because physicists tend to think that too much philosophy is bad, and philosophers think that too much science can also be bad. That's why I represented here the armchair, which is the symbol of doing a priori thinking, and basically being very, very, very far from any empirical or experimental study, and pretending to understand everything there is to know about the world from our armchair. And the second extreme is the scientific worldview, in which some scientists, especially, this is very, very hot these last 10 years, scientists thinking that science has the answer for all of our questions, very, very foundational questions that were debated for 2000 years. The scientific worldview give us the impression that no need to debate these questions anymore, because science can give us an answer to any question. Why is there something rather than nothing? There you go. What is material constitution? There you go. So you see that the 2 points of view are quite problematic, because if you reduce philosophy to the armchair, that's not good. And if you reduce science to a purely empirical enterprise, that also comes with a price. And these 2 paragraphs that I have here are just to show you that this complicated relationship between the 2 fields, it's not new. Hume very famously thought that any book about metaphysics should be thrown to the flames, because it contains no kind of empirical evidence whatsoever. Just before I go on, all these quotes are taken quite out of context, because Hume was practically talking about metaphysical discourses about creation and theology, etc. But still, for him, even if he reduces metaphysics to theology because of historical reasons, for him, any book about metaphysics should be thrown to the flames. 200 years later, people from the Vienna Circle, I don't know if you're familiar with these guys, practically there are a bunch of mathematician and physicist nerds who decided to create a very radical philosophical group in which they categorically refused any kind of metaphysical proposition, and they used to deem any metaphysical proposition as being devoid of any sense at all. For them, any metaphysical question about the world is not even wrong in this sense, because it's not testable. So you see the common thing between these 2 philosophers or philosophies is that the rejection of metaphysics is on empirical grounds. The lack of empirical confirmation vis-a-vis metaphysical debates is the problem with metaphysics. Too much, we're spending too much of our times in the armchair. And you should keep in mind that, especially for the second group of philosophers, the people from the Vienna Circle, these people knew their science. They were very, very scientifically informed. Most of them were professional physicists and mathematicians. And their main motive was that, since metaphysics is supposed to be the study of reality as it is, or things the way they should be, and since we now have science that gives us answers to all these questions, we don't need metaphysics anymore. The questions of the like should not be addressed through the armchair. We have answers to these questions through science, because in the 20th century, the revolutions in science, especially in physics, are incomparable in the theory of, in the history of thought. And so you have to understand the motive behind these assertions is that we were making a lot of advancements in physics, especially during the 30 years at the beginning of the 20th century. And this was mainly the problem with metaphysics that these guys had. So there's a conflict between philosophy and metaphysics. It has between science and metaphysics, or science and philosophy in general. It has always been there, and it still is here today. But it's here mainly because of an ignorance of what philosophy is, and mainly because of ignorance of what science really is. But the root of the problem may be twofold. First of all, it's the lack of experimental evidence for any kind of metaphysical claim. And on the other hand, there's the problem of the success of science. Do we really need metaphysical considerations when we have very, very powerful scientific theories that can really tell us how the world is? Does science really tell us how the world is, or is it some kind of tool for us to better understand a world that is in itself incomprehensible? We'll leave this till the end, because it's a question of a completely different level. So what I'm going to try to do right now is to show you that we don't need these problems, because it's because of the success of science that metaphysics itself has become even more interesting today. Because it's true that scientific theories do not settle philosophical debates, but I think that they completely transform them in a way that makes them even more interesting today, especially when we talk about concepts like time and space and the universe and substance, etc., etc. And this is my opinion, of course, do physics or science settle debates, philosophical debates? No, it does not. But at least they can give these debates they give us the chance to see them in a completely new light. So there are these two physicists who were the first to talk about the philosophy of quantum theory at in the 40s of the last century, and they famously said that physics makes negative philosophical discoveries. What does that? What does it mean, negative philosophical discoveries? It means that even though physics does not settle long debated philosophical debates, it can at least tell us what reality is not. So physics may not tell us the whole thing, everything there is to know about reality, but it can at least tell us which metaphysical answers are false. So it destroys metaphysical answers. Maybe it doesn't give us something instead of them, but the act of doing that is in itself very, very important, both to science and to philosophy. So I'm going to get to the core of my discussion. As I told you when I started, three concepts: time, substance, and the universe. We're going to start with time, but the problem with time is that there are at least 10 ways to think philosophically about time. So before talking to you about debate around the concept of time in modern physics, you have to understand that I'm not going to be talking about the perceptual experience of time. A lot of philosophers talked about this, how we perceive time. I'm not going to be talking about this. I'm not going to be even talking about what gives time its arrow, because there's a problem in physics and in philosophy today that we call the problem of the arrow of time. What makes the future different from the past? What kind of mechanism is there? And making sure that the future always comes after there's some kind of irreversibility in the way things are in nature. I'm not going to be talking about that either. What I'm going to be talking about when I talk about time is the status of past and future events, in the sense that what kind of reality can we assign to past events, and what kind of reality can we assign to future events, and what makes the present so fundamentally different from the future and from the past. So this debate is quite old. I'm going to talk about this in a sec, but before doing so, if you think about the common conception of time, it's actually very simple, because we all, here I have three examples: a poet, a painter, and Newton himself, who had a quite classical view of time. So we always think about time as being something that we have absolutely no control of, something that passes, and more importantly, we always tend to think that the past is the past and the future is not yet here. We automatically tend to assign a reality only for the present. By we, I mean us, the common people. When we think about time, when we think about the future and the past, we always think about the openness of the future. And we also think that whatever happened already happened. So the past is not here anymore. The future is not here yet. And we always cling to this present moment. And also many poets ask time to stop because they're very happy when they're young. Even Newton himself, if you read the second paragraph, he writes that the flowing of time is absolute and it's not liable to any change. So according to Newton himself, there's this absolute immense clock that is ticking in the universe, and that is the same for each and every one of us. The way I measure the passage of time, not in my conscious experience, the way I measure it biologically, or with the clock, with the watch that's on my hand, or with the clock right here on my wall, is the same for me and for you and for everyone on Earth, and for any potential observer somewhere very, very, very far away. So I chose Lamartine, Magritte, and the Newton just to show you that the first conception of time in physics, the Newtonian conception, is quite the same as the common conception. There was no new way to think about time in the Newtonian physics. And when I say Newtonian physics, I'm in the 17th century. Okay, so the way Newton introduces time in his physics is quite the same as the common conception we have about time and the change. And things are going to stay the same until probably the start of the 20th century, with the discovery or the invention, I don't know how you think about science, of the theory of relativity by Einstein. So did philosophers think about this possibility before Einstein? I'm sure they did. Even some physicists flirted with the idea, like Poincaré, like Lorentz, but we're going to give credit where credit is due. Einstein, in the year 1905, he was quite young. He wasn't even 30 years old. He wasn't even an academic. That should please you. He was
at the post office.
Exactly, at the patent office. He used to.
My bad.
To read inventions all day and try to understand if they have some kind of scientific merit or not. So this is the patent office where Einstein used to work in Bern in 1905. And in the year 1905, he actually wrote a couple of papers that are very short, but are nothing short of revolutionary. And he published them all between the month of June and September 1905. And the year 1905, we actually call it the miraculous year in physics, because everything that Einstein did in these 4 papers is going to have a tremendous effect on the development of physics in the 20th century and until now, actually. So he was going to build the foundations of the new science of the 20th and of the 21st century. So we're going to talk about the last paper, the most well-known, unfortunately, E equals mc squared. I'm going to talk about this famous formula. But before we do that, we're interested in another paper in which he introduces the concept of time dilation and length contraction, because these are the two concepts that we're interested in when we talk about the debate about the nature of time. So I'm gonna try to explain relativity with just this diagram that I drew. It's a long shot, but I'm gonna try doing it in the simplest way possible, but without maybe without losing rigor. So just a little bit of trivia before we start. Einstein himself was not happy with the title, with the name he gave to the theory of relativity. And he later said in his life that he should have called it the theory of invariance, because the theory of relativity is always misunderstood by philosophers and by the common people when they affirm that everything is relative. The theory of relativity does not mean that everything is relative. Quite the contrary. The theory of relativity tells us that there is something that is absolutely not relative and it's never going to change, which is the speed of light. So Einstein himself thought that a better name for his theory would be the theory of invariance instead of the theory of relativity. And if you can just write in on the internet today, everything is relative, and you would find all kind of misconceptions about relativity itself. Relativity does not entail relativism, be it cultural, philosophical, moral, I don't know. Okay, so no, don't use Einstein's theory of relativity to justify any kind of weird philosophical or political stance you might defend. So the postulate of relativity is that the speed of light does not change. And that's a problem. That's a problem because before Einstein, in Newtonian mechanics, we used to talk about the addition of velocities. What does it mean? It means basically that if I'm in a train and this train is moving at 5 meters per second with respect to the ground, and I'm running in this train with a speed of 2 meters per second, my speed compared to the ground would be the speed of the train plus my speed with respect to the train. That's easy. It would be 7 meters per second. But Einstein, he made this very famous thought experiment. He was the king of thought experiments. So he was the physicist of the armchair, but in his mind there was some kind of lab of some other kind. And he thought about, instead of having someone running in a train, maybe if we have someone lighting a light source. And since if we want to apply the old concept of velocity addition, we would find that for a person who is outside the train, he would measure the speed of light as being the speed of light plus the speed of the train, which was impossible, because his starting point was the fact that the speed of light should be a constant. I'm telling you this because I really want to stress that the theory of relativity is all about the fact that the speed of light can never change. You would measure it the same way as I would measure it, whatever I do and however I run and whichever way I go. So how does this affect the reality of future and past events? Because there's a conceptual jump that we're going to have to make here. But let's imagine another thing, also with trains. Maybe there were a lot of trains in Bern. We actually don't know how, but it's serious. We actually don't know how Einstein came up with the thought experiments that he did. So it sure must have, the culture maybe, or the time when he was alive must have had some kind of influence on that. But I don't know if my diagram is clear. It's not really, I just noticed, but you have two light bulbs here, the weird things. And you have a person A that is standing outside of the train and a person B standing in the train, and the train is moving with the speed V towards the light bulb that you see on the right. And Einstein asked us to consider the possibility, or to ask ourselves the question, are the two events simultaneous? I'm going to talk about the importance of simultaneity right now, but just try answering the question in your head, are the two events simultaneous? And if we think about it for a minute or so, we're going to come to the conclusion that the two events are simultaneous according to A, because since A is in the middle between the two light bulbs, the light coming from two light bulbs is going to arrive at the same time on the position where A is standing, and he's going to say that the two events are simultaneous. But the person B, since it's going really fast towards the light bulb on the right, he's going to perceive the light coming from the light bulb on the right before he perceives the light coming from the light bulb on the left. We are not used to such high velocities, and that's why these kinds of phenomena are not familiar to us. But if you imagine that the train is very, very, very fast, you can understand why B would see event on the right happening before event on the left. So who is right? And the answer would be either no one or both are right, because A is not making any kind of mistake by saying that the two events are simultaneous, and B himself would not be making any kind of mistake by saying that event light bulb on the right happened before light bulb on the left. And Einstein himself thought that the relativity of simultaneity is the essence of relativity. Why? Why is simultaneity so important? Because when you use the word, this event is present, this event is future, this event is past, how are you judging that an event is present? What does it mean for an event to be happening right now? It means that it's taking place simultaneously with my perception of it. If I say that this event took place at 3 o'clock, what does this mean? It means that the event took place simultaneously with me reading 3 o'clock on my wristwatch. The two events, reading 3 o'clock or the clock reading 3 o'clock and the event taking place, are simultaneous. But if simultaneity itself is relative, is observer dependent, then the concept of present itself and future and past would become themselves also observer dependent. But the problem is that since here on Earth, we all have relative speeds that are very, 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 very slow compared to the speed of light. The speed of light is quite fast. Huh? So since all velocities that we see here on Earth are very, very small compared to the speed of light, we would not notice these concepts. And it would make sense for me to say that this event is present, this event is future, and this event is past. But if we're dealing with very, very fast velocities, these assertions would not hold anymore. And if you're not comfortable with velocities, you can replace them by distances. Because if you have something that is not going very slow, but is very, very far away, for reasons that I'm not going to go into right now, you would have the same effect. So you would lose the simultaneity between yourself and the guy who is standing either very, very far from you or who is moving very, very fast with respect to you. So this is your crash course in relativity. I know it was really, really bad, but we don't have time to go into the details. So let's jump to the philosophical morals of what I just said, because they're quite important. I think that they're the most interesting. Today, we tend to think a lot about quantum theory that we always forget about classical relativity. So to put it into context, the debate dates back to the pre-Socratics. You probably know this. This very famous debate about the nature of being between Parmenides and Heraclitus. Quick disclaimer, I'm sure we will never really understand what these people meant by writing the things they wrote. So I'm not saying that it's the same questions that used to drive Parmenides and Heraclitus are the ones that Einstein is interested in. Okay, there are more than 2,000 centuries between these two people. We do know the pre-Socrates, but I'm sure we will never know them enough to really understand what they're saying. But if we want to put the problem into context, there was a problem with, so in a word, Parmenides was the philosopher of being, and Heraclitus was the philosopher of becoming. For Parmenides, the concept of becoming and change was, it was an illusion, because everything is. You can't even say that it already is, because there's no passage of time. So Parmenides would think about the whole universe and the whole existence as already being there, and our consciousness is only maybe traveling through this being that is the universe, with all its history already somehow written inside it. So why am I telling you this? I'm telling you this because I think it's very, very interesting that one of the oldest debates about the nature of being in philosophy, I'm sure maybe other philosophers before the pre-Socrates, the pre-Socratics talked about this, but I probably don't know. I'm not a specialist in any kind of Eastern philosophies, but the beauty about it is that you have a very, very, very old debate about the nature of being that is still relevant in the context of relativity today. Why? Because if we ask the question, Wittgenstein famously asked himself, where does the present go when it becomes past, and where is the past? And so it looks like, according to relativity, and I'm only going to say it looks like, some philosophers went all the way by saying that the debate is settled. I'm not going to do this, but it looks like that the theory of relativity, of special relativity, entails that future events and past events are as real as the present moment. I know this sounds quite paradoxical at first, but it's hard to swallow, and that's the beauty about it, because we're not only talking about philosophy of science here, it has moral implications, right? Because if the future is already there, in a way, it might affect how we talk about the whole freedom and responsibility debate. So this is quite odd, because you would never think that talking about the metaphysics of science and relativity might get you talking about moral philosophy, which is radically different from anything we do in metaphysics. I'm not saying, again, that relativity tells us that the future is already there, it's already written in a way, and you're only going through something that already exists. I'm saying that it seems that the most common interpretation of special relativity today accepts the idea that past and future events are as real as present events. Einstein himself battled with this idea. You can read what I got here from Carnap's biography, saying that the concept of now was very hard to swallow for Einstein, because he thought that the concept of now is meaningless in physics. My now, in the sense that my present, is radically different from yours. It's actually not, because we are very close to each other and we are not moving very fast one according to the other. But if we were moving very fast one according to the other, or if we were living very, very, very far away, and by very far away, I mean billions of light years away, these effects would be tremendous, and that your now would be radically different than my now. What I consider to be past events, the death of Einstein, and future events, the, I don't know, potential earthquake that could hit, are future and past. But for someone living very, very far away and moving just a little bit closer to the Earth, these events might both be past or might both be future. And if they are both past, we don't have any way but to say that they have some kind of reality. And it's do we talk about this today, you might ask me, and the answer is yes. But if you're looking for an answer to this problem, or even if you want to discuss this problem, unfortunately, it's not very much discussed in physics circles. It was exiled into the world of philosophy You see, philosophy of physics as an academic branch was born quite late, because at the beginning of last century, the physicists themselves were doing philosophy of physics and philosophy of science. But after the 50s, we now have physicists who only work on physics, maybe making the world a better place. And whenever you want to think about these fundamental questions, you're going to be exiled to the world of philosophy of science. At least that's what happened to me. But just a heads up, because the people who used to think about these questions were the physicists themselves. And the beauty about Einstein is that he really tried to understand what his equations are telling him. He wasn't only making equations claiming that he is discovering how the world works, because he really thought, if you look closely at his writings, he really understood what was going on with contemporary philosophy back in the day. Okay, so I told you before, I'm not going to go as far as Putnam. Putnam is a heavyweight analytic philosopher. So he wrote a very important paper in which he actually he tells us that he actually thinks that relativity settles the debate. And he is sure that future things and events are real, and likewise all past things, even though they don't exist now. So there's some kind of spatialization of time that is very, very radical, because you would all agree that the Eiffel Tower exists, even if we're not there. We're all here. We can't see the Eiffel Tower. It's not in our proximity, but no one would tell me that it doesn't exist. So people who take relativity very seriously would do the same thing with temporal events, in the sense that the potential earthquake that is going to happen in 10 years exists in a way, but we're just not there yet. Okay, so
yes, I just a second, because this is, I think this would be a bit difficult to digest for people who know absolutely shit about this. What the fuck does it mean that the past and the future are as real as the present? Like, I know you've already spoken about this, but I mean, it, like the thing, how can we make it more tangible for us? How can we understand it? And the potential earthquake is already real. Is it that it's Is it that it's going to happen whether or not we like it, or is it because what does real mean here?
That's a very important nuance that we have to make here, because in the debate about the nature of events in relativity, you have philosophers who think that events are real in the sense that what you just said right now, they're going to happen whether we like it or not. But some would say that they already have a reality, just like past events have a reality. You would say that the fact that Socrates drank the hemlock and died actually happened in Athens 2000 years ago. And these people would tell you that whatever future event is going to happen is already here in a way. So when you're using language, when you're using the act of becoming in your language, this is where you're making a mistake. Your consciousness is making you a prisoner of the present moment, but actually the outcome is already here. Maybe like when you're watching a movie, the ending of the movie is already here, but you're just not there yet. And maybe your consciousness is stuck in this perceptual flow of time, just like your body is stuck in Beirut right now. And if you want to go to New York or to Paris, it's gonna actually take there's work to do. You can go, but there's still this difference between space and time, is that in space you can always go backwards, and whatever backwards mean, but
Roman
in time you can't.
is asking, so linearity in Newtonian linearity in Newtonian mechanics or physics is incorrect?
There's still some kind of linearity, because the idea of the way time is flowing from what we call the past to the future is due to another physical theory. We're going to have to go into thermodynamics. There's actually a physical law, and I say law because it's a probabilistic law that makes things happen the way they do happen, in the sense that things always tend to become more disordered, and what you call the future is always quite more chaotic in a physical sense than the past. But you can save linearity. I don't know if I'm answering your question, but you can save linearity in this conception. If you want to go to the linearity or possible cyclic happenings in time, we're going to be either talking about thermodynamics, or we're going to have to jump to general relativity, the other theory invented by Einstein 10 years later, which accepts time traveling solutions. But I just didn't want to go into this right now because okay. I don't want to flirt with science fiction. So in the end, if you still have a question about that, because I'm not sure that I answered your question, we can get back to this problem. Okay. So
and one last thing, sorry, but I have to, because it's before we jump to maybe before you continue, where does change come in here, or is it also related to thermodynamics and whatnot? Like, can we talk about change?
No, no. It's change in a perceptual way. You see things changing because you are moving in space-time.
And at an individual level, how does that? So we're already.
But things are. You just have to accept that everything is. A la Parmenides. What does this mean for our perceptual experience of time? I don't know. And Einstein thought about that, and he actually met with Bergson. And you know much better than myself that Bergson was crazy about the idea of perceptual experience of time. And they did meet and they did talk about this, but again, I just didn't want to spend the whole lecture talking about time. But I started with the most dangerous thing. The other two concepts are softer and are easier to swallow than the concept of time.
Interesting. But I had to just mind fucking blowing. Yeah, I just had to ask the question because it's so that we at least try to wrap our heads around it a bit.
Einstein himself never, in my opinion, he never got to wrap his head around it. Never. Because he really believed that this is what his physics told him, and Einstein was a realist in the sense that he really believed that science gives us a complete, clear picture of reality. He wanted to believe his physics, but in a way, on a personal level, he had the same problem that you have and that I have. It's that it's very hard for us to accept that future events, past events, maybe not a problem there, but it's very hard for us to swallow the so-called reality of future events, whatever that means. But I don't know. But it's still a topic that is very hotly debated today. You can read a lot of things. The debate today, it's not called being and becoming anymore. It's mainly called the debate between eternalism, people who believe that everything already is, and presentism, people who think that only the present is real. So eternalists think that everything is, presentists think that only the present is real. It's related to the philosophy of language today. So it's the debate is quite big in philosophy circles, but it has a completely different taste today. You know what I'm talking about. It became quite too academic. But in Einstein's last years, it was really a moral, if I dare say, problem for him. He really thought that physics is making him take a moral philosophical choice. Yeah.
Not so much when they tried to put together the hydrogen bomb, but yeah.
Yeah, I'm going to talk about this actually right now, because my second talk is about substance, another favorite topic in philosophy. Substance. What is an object? Metaphysics is the art of making everyday objects seem very, very hard to understand and to characterize. So in this part, we're going to see that the revolutions of the 20th century, starting with Einstein, then in quantum theory, they have completely dematerialized matter. I know it's paradoxical, but today, I know in high school chemistry and physics, that's what they teach us, right? That matter is made up of atoms. Atoms are made up of a nucleus, and the nucleus contains, etc., etc. And they always give you this idea that particles are like these little material constituents, because they themselves make up matter. But if you really ask yourself, what are particles? The only answer that science can give you is that we don't really know, but it doesn't seem as material as that. That's the best answer I can formulate right now. So what do I mean by this? The question that we're going to try to answer is very simple. What makes a physical object? What do I mean when I say my mug is a physical object, my bed is a physical object, my body is a physical object? And we're going to see that the question itself is quite hard to answer, and that with the revolution of 20th century physics, it became even more hard to answer. And you're going to see the effect, this negative effect. Negative is not something bad. I mean it in a positive way, because it's going to destroy our common conceptions about the materiality of things. So if we I don't know, I tried thinking about what I would think makes a body a body, and I think that we can all agree that it's something concrete, in the sense that it's not abstract like mathematical entities, for example. It's concrete, it's there, it's material, it has mass, it occupies a space, persists through time. We can forget about this now, and it exists. Just to be clear, I'm not going to talk about existence, because I would have to go very deep into quantum mechanics, and we don't have time to do this today. And I'm not going to talk about the reality of abstract concepts, like the things invented by mathematicians. Do they have some kind of reality or not? I'm only going to focus on the mass part, because we would all agree that every object in your room right now has a certain mass. And you're going to try to understand how the concept of mass itself has evolved from a long time ago, with the pre-Socratics, maybe, because they are the first to introduce the concept of atoms. But of course, the atoms of the pre-Socratics has nothing to do with our modern ideas of atoms until today. But I always give you the conclusion in the beginning by telling you that most of physicists would agree today that it doesn't have any sense to apply these concepts of materiality on the constituents of matter. The constituents of matter themselves are not material. Where does this property of materiality emerge? I'm not quite sure. Okay, so 3 blows. Again, I'm being. It's horrible how bad my exposition of these physical discoveries is, but we don't have much time to because modern 20th century physics is so it evolved very fast that we actually really can't keep up philosophically with everything that is happening. So I chose 3 steps in the history of physics that can be considered as being assaults on the common view about matter. The first one being the mass energy equivalence, 1905. That's what you were talking about right now, Einstein's relationship with the bomb. It has nothing to do with what I'm going to talk about, but I think we should talk about it for just a minute, because I have a poem here, but it's in French. Sorry, I couldn't translate it, but he's actually saying what you were saying, is that Einstein didn't really care about us when he was writing his equations, because they led to the construction of bombs that are going to kill thousands and thousands of people in a second. So Einstein discovered the most famous physics in the most famous equation in physics in 1905, the energy mass equivalence, E equals mc square. what does it tell us? It tells us that mass and energy are two interchangeable properties of matter. You can actually change the mass of something into energy and the energy of something into mass. And actually, we know today, this is the first philosophical moral, is that most of the mass of the body is not due to the mass of its constituents. That's very, very cool, because in philosophy, that's what we call materiality, the study of the relationship between the parts and the whole. You would think, and the normal, the conception of matter would say that the whole is the sum of its parts. But the equivalence principle tells us that it's not the case, because 90% of your mass and the mass of this table is not due to the sum of the masses of its constituents. So if I take the mass of all the protons and neutrons, etc., that make up this table, I would only get around 10% of the mass of the table. The 90% would be the mass due to the huge amount of energy that is present in these constituents, keeping them glued together, etc. That's the first philosophical moral that we can get from Einstein's discovery in 1905. So the picture that I have here has nothing to do with what we're talking about, but you can't talk about E equals mc squared without thinking about the bomb. Even the Times, they famously drew Einstein with the whole mushroom cloud behind him and the equation E equals mc squared. So in our common conception, Einstein is the man behind the bomb. That's not quite the case. In a minute, the process that made the bomb possible was discovered in the 1930s. So it was thought about more than 25 years after the discovery by Einstein of his famous formula. He never thought about it before. It was discovered much later with the works of the Curies, Leo Szilard, Enrico Fermi, etc., etc. And when they talked with Einstein, because Einstein was already a rock star back then, and Einstein became famous in the 1920s, like really, really famous. Since he was famous, and since he was already exiled in the United States, when the physicists who were involved with the process that makes up the bomb, they thought that the Germans are on the brink of producing an atomic bomb. And since they were scared because they knew that the regime in Germany was capable of everything, especially the worst, they wanted to take this problem to the highest authorities in the United States. But no one would listen to them, because who would listen to a random physicist from Hungary? So they went to Einstein through Niels Bohr, and they asked him to write a letter to Theodore Roosevelt, urging him to do something about the fact that the Germans probably, because they still had, most of physicists flew Germany after the rise of the Nazis, but some stayed. Heisenberg, for example, he stayed in Germany. And these people thought that since the Germans still have a couple of very intelligent physicists, they would themselves discover nuclear fission and produce a nuclear bomb. But when Einstein said this, wrote a letter to Roosevelt telling him that the Germans might be developing a very, very big bomb using the energy of the atom, things that Roosevelt probably didn't understand, this is how the Manhattan Project was born. And this is why 4 years later, the Americans were able to develop the atomic bomb. Einstein was wrong. The only fault is that he thought that the Germans would be able to construct the bomb, because we later discovered that the Germans were not building any kind of atomic bomb. And then it was too late. When the Americans already produced the bomb, it was too late. The Germans had already lost. So they looked around, and Pearl Harbor had already happened. I'm no historian, but that's how I think things happened. And the poor Japanese were chosen to be where the immense power of 20th century physics was going to be shown off. So yeah, and when Einstein knew about the bomb being dropped, he was actually very sad that he was very indirectly the reason the Americans thought about building the nuclear bomb. Okay, my monologue of 10 minutes was just to try to to relieve Einstein of the moral burden of killing thousands of people. So it's not only because of E equals mc squared. Back to philosophy. What does it mean? First of all, it means that most of the mass of the body is not due to the mass of its constituents. So the whole relationship between the sum and the parts, which is a very old metaphysical debate, has to be thought about again. Second step, 2 years later, Einstein started developing his theory of gravity. General relativity is going to take him more than 10 years to come out with the right equations. It was a very laborious work. It's intellectually immense, because it's very rare in the history of science to see so much work being produced only by one person. And he discovered something that is interesting for us in our concept of mass. He discovered, and what he later called the happiest thought of his life, is that when you have a freely falling body, this freely falling body would not feel its own weight. In physics, this is very important, but in philosophy, it would be important. Why? Because what actually makes you fall is your weight. And paradoxically, when you're falling because of your weight, you would feel weightless. So that was a very, in physics, it had very big implications. But I think philosophically, it's a cute way of looking at things. I'm going to get to this later when I finish with my third assault. I'm going to talk about 40 years of quantum theory in 1 minute. I'm not going to go into the details of quantum theory now. This needs a whole talk in itself. So no Schrodinger cats, no people going through walls and being two places at once. Although we should do this one day, because quantum theory may be the most misunderstood, philosophically misunderstood scientific theory. But in a sentence, quantum theory we started developing it in the early 20s, also due to one of the papers Einstein wrote 15 years earlier. 30 years later, it became one of the most developed scientific theories, because it's very powerful. It doesn't make any sense, but it makes very important predictions. It works. Quantum mechanics works. I'm able to talk to you through my computer because of quantum mechanics. So even though it doesn't make sense philosophically, we don't really understand what it really means on the most fundamental level, but it works. Anyway, why am I talking about it right now? Because there's something very well known. You probably heard about it 5 years ago, the God particle. That's the most horrible name someone could have given to a physical particle. Actually, they didn't want to call it this way, but you know how the hype around physics is today, especially in the popular accounts. And through the Higgs mechanism, I'm really going to explain it in 1 minute. You know, the Higgs particle, the God particle, we built this whole collider just to discover it. We discovered it in 2012. People were crazy about it. Conspiracy theorists thought that the world was going to end. Some really think that the world did actually end, and something weird is going on in this place. Anyway, it was a very the event was a mediatic event that's quite rare in the history of science. And why is the Higgs mechanism philosophically important for us? It's because we discovered, using quantum theory, when we started studying the most elementary particles, it means that when we started studying what reality is made of on the most fundamental level, we discovered something very paradoxical, is that none of the elementary particles should have mass to begin with. All of our mathematical model entails that all the particles were massless. So physicists in the armchair, they were pure theorists, they came up with this mechanism that would give to all the particles its mass, in the sense that if you take a massless particle and if it moves through this existing field everywhere, the fact that it interacts with this field is going to slow it down. And by slowing it down, it's going to give it the property that we call mass, right? Because since this thing is if the thing has a very, very big mass, it would take it more time to go through a medium. So this medium, this field, as we call it in physics, is everywhere in the universe, and these particles interact with it. The more strongly they interact with it, the more mass they have. It's very complicated. It's purely mathematical. The beauty about it is that physicists actually invented it in the 60s using only maths and their imagination. And it turned out to be true, because there's something that tells us in physics that every field has a particle. And we discovered this particle in 2012 in the Large Hadron Collider. But philosophically, why is this interesting? It's because, as I told you before, what Einstein told us is that most of your mass is not due to the mass of the particles that constitute you. But then we knew that even the constituents of these particles, the smallest constituents there are, they're called quarks, they don't even have mass in themselves. They only acquire mass because of an interaction with something that is not themselves. And here we have a philosophical treasure, because we now know that mass is not an intrinsic property of matter. I think that mass is the most intrinsic property there is. An object has mass. But today we know, first thing, that most of the mass of a body is not due to the mass of its constituents. And second of all, the mass of the constituents is not some kind of fundamental property they possess. They only have it, they mimic mass because of the interaction with something that is not themselves. And physics is telling us that we only have the behavior of something massive, but we don't have mass in itself anymore. And this has tremendous implications on the concept of materiality in itself, because in a way it's very far-fetched, it's hard to accept, but apparently it's the way it is. Because using this mechanism, we came up with what we call the standard model of particle physics, and it's one of the most successful physical theories that we have. So there you go.
I'll stop you first.
Yes.
One thing here, Dghem said we needed a war to initiate Manhattan Project, eventually to have the greatest source of sustainable energy.
I'm sorry, could you repeat that?
We needed a war to initiate the Manhattan Project in order to be able to have one of the greatest sources of sustainable energy.
I totally understand. No, it shouldn't have been the case. No, but it should. This should tell us something about human nature, because you had a scientific discovery telling you that there's a tremendous amount of energy you can use that is in the atoms, and we chose to use it as a weapon way before we started constructing our first nuclear reactors. I totally understand. Unfortunately, it's the way things happened, but they shouldn't have happened this way. No, but the mechanism for a nuclear reactor was there. Before we could have, I think we could have had a Manhattan Project just to create a greener energy or a more sustainable form of energy, not to construct a bomb. But politically, I'll leave this to historians and of the 20th century. I don't know why things happen this way, but it's sad indeed. Yeah,
because it's all power and power struggle, as Foucault would say.
Yeah, that's he did characterize physics and biology in this way, but let's talk about serious things tonight.
Thank you. Fuck yes. Yeah, well, the funding part is something else, but Saidiki, this we would be discussing, I think, Feuerab. And the other question that Suhad is asking is, and this is why, yeah, I'll get to it. Feuerab and the funding that Dream just said, pointed out. So the soul-body dichotomy does not exist, since the body itself does not have a material existence. It's like, how can we think about these body soul, like Descartes' dualism, if you want?
That's a tough one. I was planning on getting into this famous relationship.
If you are, then we'll keep it till afterwards.
No, I think it's something we have to address. I'm already way into this thing, but weirdly enough, this form of dualism survived worse than this. Yeah, you have philosophers physicists who worked on quantum theory, who got really into the heart of these things that I'm talking about, and somehow it didn't dictate what they should or what they do think about this dualism between body and spirit. Just like we were supposed to see later how the guy who actually discovered the Big Bang Theory himself was a priest, and he never had any problem or religious creation. So you can find physicists in both camps. Some would say that they do not believe in this because they do not believe in this, maybe for moral reasons. Some would say that they don't believe in this because physics says so. And some who actually believe in the physics and champion this physics who still believe in it. So we should actually make statistics, but it's very hard to know which physicist was driven by his physical discovery to have a religious worldview or an atheistic worldview. That's a very, very interesting topic. But unfortunately, it was very intellectual in the 20th century, even before that. But today it's horrible. Today the level of scientism that you can find in books about atheism is really, it's an insult to anything philosophy or science should be. Writing a book of 100 pages telling you that science or physics proves that the universe can exist by itself, or that science proves that you have nothing going on there except for electrochemical reactions, is an insult not to philosophy but to science itself. That's what I think. Yes, I'm not defending any kind of worldview here, yeah, but let's not reduce the whole debate about religious metaphysics and science to 2 or 3 books that were written in the past 15 years. These questions are very, very hard to address. Should we take into consideration what the scientific worldview? Of course, but I think we're not going to get to conclusions that fast. It's something interesting to talk about, of course. I'm not saying that no one is talking about it in the right way. Huh? I'm just saying that usually the hype around scientism and atheism was quite strong, especially the last 10 years.
Call them by their names, man. Richard Dawkins.
No,
and the new atheists. Call them by their names.
Yeah.
And this is why analytic philosophy sucks now, because what was initially supposed to be an understanding of the fundamental kind of aspect of reality and physics became all about shitty stuff. So they're not doing that anymore because of this separation between academia and the actual people who are working at like the physicists.
I agree. Of course. Plus, you have to take into consideration the whole politics of funding, etc. Of course. It's you can't separate anymore science, philosophy, and politics in the sociological sense. Yes, but that would be just like you said. We would have to talk maybe more about Popper and Feyerabend, but. It was a very tough decision deciding what to talk about. But yes, of course, these all are very, very relevant topics that should be discussed.
Yeah.
And by should be discussed, I mean in a non-academic setting, just like this one. Yeah.
And by people who at least understand the subject, not people who have nothing to do with science the philosophy of science, and then they go give talks about or courses about psychiatry. Let's keep it.
That's my plea. In the end, I was gonna end things with a plea for a more scientifically informed philosophy. So yeah,
there's one more question from Nick. I'll keep it till later so that you can.
Okay. Do you think I'd rather skip the last part to conclude and we talk about?
As you wish. Like you can maybe 5 minutes to discuss this.
Yes, 5 minutes. Okay, yeah. And I'm gonna actually.
The beauty of online is that we don't have anywhere else to go, especially.
Yeah. Of course not. But
and people can just log out anytime they want.
Yeah, exactly. This can be quite detrimental for my ego, but why not? So. We get to the biggest topic of them all, the universe itself, Big Bang, and another word that is quite misunderstood in pseudo-philosophy today. 5 minutes.
Yeah, sure.
I'm going to skip this whole part. You all know that questions about the origin of the universe started a long, long time ago. We don't have any culture that does not have its own cosmogony, that doesn't have its own discourse about the origin of the universe, from the Greek myths to I don't know. I'm not a specialist in mythology nor ancient religions, but still, culture presupposes some kind of theogony. If you want to know which dates are important or which steps are important in the development of cosmology, that would be the Greeks. I only know about Aristotle's universe, not so much about what the Stoics or the pre-Socratics have had in mind, but the main model of the universe that was in part due to Aristotle, Ptolemy, etc., and the people that came after them, and that's the cosmological model that lived the longest. It outlived the one we believe in today because it stood the test of time for more than 2,000 years. What you have to know about this model is that it introduced a fundamental distinction between what happens on Earth, which was at the center of the universe, and what happened in the heavens. So you can't apply the same laws that you apply on Earth, that you would apply on Earth, to the heavens. Okay. So the first blow to this model was what we call the Copernican revolution. It's a very, very complicated 200 years in the 16th and 17th century. The big names: Copernicus, Brahe, Galileo, Kepler, not in any chronological order. The Copernican revolution, it's not about taking out the Earth from the center of the universe and putting the sun. This would be quite ridiculous to reduce the Copernican revolution to the switch between geocentrism and heliocentrism. It was much more important than that. It was a revolution on all levels: political, scientific, philosophical. And this is why I chose this particular excerpt from Galileo's dialogue concerning the two chief world systems. I'm sure you're familiar with Galileo, but I would urge you, if you want to read an ancient scientist, it should be him, because the guy he wrote in a crystal clear way And this is why he's so well known. He refused to write in Latin, which was the lingua franca of academia in Europe. He wrote in Italian. He wrote in dialogue form. He used to hate on everyone. Anyway, you can read Galileo, you can read Feyerabend, who studied, or Coiré, they studied Galileo in so much detail. Anyway, the Copernican revolution happened. It took a while. It was one of the most bloody, intellectually bloody revolutions in philosophy and in science, because Aristotle was seen maybe as some kind of dogma with the whole theological background. Anyway, I wanted to talk about this, but we can easily skip this part. What I'm interested in is what happened after the Copernican revolution in the 20th century. Very, very fast. Three actors. Einstein again. I wanted to put Einstein on the forefront of my lecture, because I know he's the most famous scientist, but I think that he's so well known that he's not known as he should be. Because when you're too famous, we tend to misunderstand what you really did. Same 10 years, Einstein developed, there he is right here, he developed his general theory of relativity. 2 years later, 1917, he discovered that his theory of relativity, general relativity, it's an immense theory, much more intricate than the special theory of relativity. He discovered that you can apply his theory to the whole universe. And this is the philosophical revolution I wanted to talk about. It's because after relativity, and it's not only due to Einstein, of course, it's due to the other people who worked on it. We now know that the universe is an object, a physical object that we can study. Before that, we used to think the universe as being this thing that contains all things. It wasn't a thing in itself, okay? It was maybe some kind of sum of all things. But with modern cosmology, the universe itself became a physical object that we can study theoretically until the 1930s, then experimentally. Today, cosmology is an empirical science. Some people might have difficulties accepting this idea, but today we have empirical cosmological discoveries that make the model of the universe that is accepted in scientific circles today quite strong. We have made predictions about the expansion rate of the galaxies, about the cosmic microwave background, etc., etc. Just to tell you that today cosmology is an empirical science. It started due to the all-encompassing power of general relativity, especially by these guys around Einstein, De Sitter, Eddington, Lorentz. The guy in the middle is a very dark figure in physics, Ehrenfest. The guy killed himself. Anyway, his life is very tragic, so we honor him here. The guy in the middle is the most important one, Georges Lemaitre. He's not very well known. He's a Belgian mathematician, physicist, and astronomer. And the curious fact is that he was a priest and a heavyweight intellectual back then. He's the first one to understand the importance of Einstein's equations to cosmology, himself and Friedman. That's why I call this part the unnoticed revolutions, because no one talks about Alexander Friedman and Georges Lemaitre. You probably, maybe you never heard of them, but and then so Lemaitre, just just to a historical lesson here, he actually discovered Hubble's law before Hubble. You know Hubble, the guy who discovered experimentally that the universe is expanding, and the law of the expansion of the universe, we actually call it Hubble's law, but Lemaitre discovered it before him. Theoretically, the guy was no astronomer in the empirical sense. He discovered Hubble's law before Hubble. And the most important part for our talk, he was the first one to have the idea of what we call today the Big Bang. He wrote a book about what he calls scientific cosmogony. The expression in itself is beautiful, scientific cosmogony. So it's a discourse about the creation of the universe, but it's scientific. He thought that relativity and the modern cosmology were all telling us that the universe a long time ago was very, I'm going to have to be very careful here. It was much smaller than it is today and much hotter. okay? Please, the Big Bang Theory does not say that there was nothing, then there was this big explosion, and everything came out of existence from nothing. It does not say that. Any discourse implying that the Big Bang is a theory of creation is only due to a miscomprehension of the physics and the philosophy involved. Everything, and I'm talking about, I'm not talking about speculative science. You noticed I didn't mention strings, superstrings, multiverses. These things will probably turn out to be true. I don't know, but I'm talking about relatively well-established science. The Big Bang model, we don't really call it the Big Bang theory, it's the hot Big Bang model, although it was introduced by Lemaitre in the 1930s. Einstein, he met Lemaitre, he thought his physics was atrocious. Einstein was completely against any kind of theoretic, scientific theory that would give you a creation out of nothing. He even didn't understand Lemaitre's ideas at first. But I think if you want to understand the Big Bang Theory, it's better to start by what it is not. The Big Bang Theory is not a theory of creation. Everything that the Big Bang Theory tells us is that the universe 14 billion years ago was much smaller than it is today. I didn't say it was too small because we don't have anything to compare it to, and it was much hotter. And since then, it's only expanding, in an accelerating way, and cooling. And this is very important because today we treat the universe as a physical object. We can empirically study it. It has a history. We know the history of the universe we live in. We try to discover its shape. That's what we call topological cosmology. That's not important. And we try to understand how it might eventually come to not an end, to some kind of end to this cycle, maybe, I don't know. But that's a very important philosophical lesson, is that the thing that used to contain all things is itself now a physical thing that can be studied theoretically using the mathematics of relativity and empirically using observational cosmology, which is much, much more precise than you might think, really. The second part here are the problems with cosmology, or the philosophical problems that we might face in modern cosmology today. The fine-tuning problem, I'm not going to talk about this. The problem with the initial singularity, no, the Big Bang Theory does not tell us that there was a point containing everything that then exploded. We only write this when we want to sell books, popular books about science. And I think these popular books are actually quite hard to understand, and they do a bad job. I'm not saying all books, some are really, really, really good. But if you read somewhere that the initial singularity, as they call it, is a point, physical point containing everything, then it exploded and it gave birth to everything else, that's not true. It might be true, but that's not what established science tells us today. The singularity, the initial singularity, is due to the fact that if you go back in time, you're going to come to a time that you can't you can't go further than this point, because your theories break down. Relativity breaks down, quantum theory breaks down. You're going to need what we call a quantum theory of gravity. Do we have a quantum theory of gravity? Not yet. Since we don't have the theory, let's not speculate about the beginning of the universe. The Big Bang is a theory about the evolution of the universe from a time,
if at all.
It is quite empirically established. It has its problems. But it is quite empirically established. We'll talk about it, but it's not a theory of creation. That's why I wrote The Trap of the Why Something Rather Than Nothing debate. Science, be it the Big Bang Theory or quantum mechanics, does not explain. It's not its job to explain why is there something rather than nothing. This one of the oldest philosophical problems. It's not here to resolve these kinds of metaphysical questions. Should they be addressed? Of course, but we don't have the right as self-respected scientists today to say that science resolved the question of even Lemaitre himself, because he was asked, He never used the word Big Bang. Actually, the word Big Bang, Fred Hoyle used it. He was mocking, he was making fun of Lemaitre. He used to call him the Big Bang man, because he used to think, and he used to believe in another theory, according to which the universe always was. Einstein also believed in this, at least at first. And even Lemaitre himself, he always talked about this difference between physical beginning and metaphysical creation. Metaphysical creation, for Lemaitre at least, it was some kind of act of God. I don't know. Was it? I don't know. But does physics or cosmology tell us that it was not? Not that I know of. And again, I'm not defending any kind of view. I'm just going against the current, because this is what you would probably read in most popular account of scientistic/atheistic science today. And this is why I finish my thing with the slippery slope towards pseudoscience. When you read things about the multiverse, I know that they're very exciting. Multiverse, these things might turn out to be true. The Higgs mechanism turned out to be true. They might be, they're mathematically solid, but they are still in the realm of speculation. They are not established science, at least scientific facts, at least yet. And in order to stop talking after 1.5 hours, I'm gonna, we actually, without wanting to do so, we talked about this, what I called this inevitable complicity between science and philosophy. This disdain that we have towards philosophy is not beneficial, neither for science nor for philosophy. If you do believe in it, it's probably due to a misunderstanding of the way science operates. That's not only the fault of scientists today, it's mainly also due to the fact that science is not taught in the best way possible. In school and in academia, you can have a PhD in physics without taking any course in the history of science, the history of physics, the philosophy of science. So do you need the history of physics to actually become a great physicist? Of course not. Feyerabend used to call these new physicists savages, because they were so anti-philosophical that they do not resemble at all the intellectual heavyweights that were Einstein, Schrödinger, Bohr, etc., etc. People who not only knew their science, they knew contemporary philosophy, they were interested in cultural debates about the nature of science and about the implications of science, much more than the view that we have today of the scientist who is a nerd sitting in his room only watching science fiction movies all day. That's not how science was. It's not only about, not that there's anything wrong with science fiction. I'm just saying that this new idea that we have of the scientist that is not interested in the arts, in literature, and the history of his own field is actually, in my opinion, detrimental to science itself and philosophy. I invite you to discover Sellers. He's an analytic philosopher, unfortunately, but he wrote a very nice idea about the difference between the manifest image, which is the image that your senses and culture gives you about the world, and the scientific image, which is quite radically different. And he tells us that he thinks, at least, that philosophy, its job is to try to bridge this gap between the manifest image, the cultural image, the perceptual image of the world, and the image that science is giving us today. And finally, we have to accept the fact that, at least historically, we cannot separate the development of science from the development of everything in our intellectual history, be it the arts, music, literature. And we stop teaching science this way. Today, we're teaching science for future scientists and everything else for people who will never be able to do science because maybe they're not considered to be as smart. You know, I teach little kids physics, so this is the teacher in me talking. Let's not forget that there's as much beauty, reality, and precision in science, in literature, in music, in the arts, and in everything. You can't separate science, physics, or any kind of science from the intellectual heritage from which it stems. In the end, even if it's supposed to explain the world as it is, it's still a very, very human enterprise, and we have the tendency to forget that. Thank you. I'm gonna I'm gonna stop.
Thank you very much for this. A lot to digest, and I have so many questions now, but I'm not going to be asking all these questions now. We can move that private later on. I'll pester you with WhatsApp messages, but first I'll go over because you mentioned something about predictions and cosmological, and Nick has something to say about predictions. So maybe they're related, maybe they're not. I'll leave it to you. But when it comes to predictions, I automatically, it's like I feel it's, I don't know. It's like the word when it's used around by social scientists, for example, it's alarming up to a certain point. And I don't understand shit about this, but do you have a view on the connection between theories making accurate predictions and describing underlying reality accurately, or is reality underdetermined and therefore multiple theories could make equally accurate predictions?
Yes, thank you for the word underdetermined. Yes, there is a flagrant underdetermination of reality by science. Of course, if you look at the history of science, you can see that so many times we had 2, 3, 4, 5 competing theories that give out the same results and hence the same predictions, and there is no way to choose in a scientific way between them. Thank you so much for this question, and I'm going to tell you my view in the end, but this is a very important topic in the philosophy of science today in general, not only in the philosophy of physics, simply to know are our best current scientific theories actual reflections of the way things are. And if you say yes, you have a problem. If you say no, you have a problem. Because if you say yes, you wouldn't be able to explain what you're talking about, the underdetermination of theory by experiment. And you can't explain the history of science itself, because we know today that our best theories 200 years ago are replaced by better theories today. So this would make us tend towards saying that science may not be giving us a true picture of how things are. It's only a tool that helps us make prediction and make a bit more sense about how the world works. But if you go into this is the view, we call it instrumentalism or anti-realism. But if you go too far in this instrumentalism or anti-realism, you would have to face what they call in philosophy of science the no miracles argument, because if you believe that science is a purely instrumental enterprise, it would be quite hard to explain some predictions that science made and turned out to be so precise that it would be considered quite a miracle for this to have happened by chance. Because there are some times that quantum theory, for example, predicted some kind of quantum number with 12 decimal places in theory using the mathematics, and then when we measure it experimentally, we'd actually find out that it's the same. If you want a more tangible example, you can take the example of the planet Neptune, which was discovered mathematically. It was not discovered by observation. We had a problem with the calculations of the orbit of another planet. So we postulated the existence of Neptune with its math, with its orbit, etc. And it turns out that it's actually there. So that's the problem, is that if you take it too far, you'd have a problem with explaining how science evolves. And if you take it too far the other way around, you would have a problem explaining what makes science so powerful, or at least much more predictive than what the so-called social sciences. Mahmoud, you asked me if I have a say on this. I suppose you asked me if we can actually consider the social sciences as being sciences as such, I'm afraid to say no, because when you say no, people might think that you have some kind of disdain toward the other disciplines. So I would say no, but that's not a problem, because philosophy is not a science, the music is not a science, the arts are not a science. But I'm sorry to say that they give me as much pleasure as science does. So first of all, it's not a problem for an enterprise to be not scientific.
Exactly.
Second of all, if you want to take the physics, because there's a word for this in sociology of science, it's called physics envy. Physics is so predictive that mathematics are a completely different league in their own. But in the natural sciences, physics is so predictive that some sociologists consider that all other branches of knowledge have physics envy. They want to be as predictive in order to be labeled as science. I think that if you put if you want to consider the scientificity, the something scientific, using physics as an example, you would be putting the bar too high, because it's quite predictive, much more than even other respectable branches of science like biology, etc. Not because it's more powerful, because maybe the things that physics deals with are more easily or more empirically accessible. I don't know. But where to put the limits of science, we can talk a lot about this. But the problem with realism or anti-realism is going to stay here. I think it's not going to get resolved anytime soon. But it's interesting to talk about it. And if you want to be an anti-realist, meaning that you don't believe that science shows you the world as it really is, we would still have to acknowledge that science works. And you can take that's what I do. I have a very pragmatic vision about science and physics in particular, is that it works. It gives you results. Most of them they're supposed to make our lives better. And this gives it a certain criteria of truth. Is it the ultimate truth? Of course not. Of course not. Yeah, I don't know if I answered your question, but
yeah, you kind of did. But I mean, yeah, but that would be, I'll keep my questions till later. So Zahi is asking, what gives a material existence, present existence, its interaction, if I'm not mistaken? And another question, where does the transformation fall in all of this? Someone might already have, yeah, I don't know. So
exactly, the transformation is the same question of because you asked me about change. Yeah, exactly. So the transformation would be taking place only in your perception of what is going on out there, because what is out there already is. So it's your motion somehow through time that gives you the illusion of becoming and the change. But becoming and the change would not be fundamental in this way.
Did you just validate Kant?
I didn't want to go into this, but there are neo-Kantian philosophers after Einstein, because most of them after Newton were, because Kant himself based most of his ideas on Newton. But Cassirer, for example, he was a neo-Kantian, and he thought that Einstein and Mach before him, in a way, vindicate Max's ideas. I tend to see things differently. We can vindicate Kant somewhere else, especially maybe in quantum theory, this idea that the thing in itself is inaccessible. Something that quantum theory tells you that there's not even a thing in itself, saying that there's only perceptions. We can talk about this some other time, but yeah.
But I meant when it comes to our perception of time and space, as in it's because you're saying, so there's the space-time outside that physics can understand, but then our perception is basically conditioned by our perceptive apparatus, or
yes,
by the senses.
that's exactly that's the whole part I omitted by saying that I didn't want to go into the details of perceptual experience of time. One, because I'm no expert in the field. Two, because it's fundamentally different, because physics doesn't say anything about it, at least for now. You're going to have some kind of developed theory of consciousness. I don't know. I don't know. That's the best answer I can give you.
If we go back, Suhad is asking, if we go back to the first part, all these events are simultaneous. Did the universe evolve? It depends on what a great, oh no, that's something else. And thus we cannot reduce reality to science or attach it exclusively to science.
Well, maybe we can't, but why I don't see the point between the two statements. I agree with the second one. Yes, there is, I think, a fundamental part of reality that maybe is inaccessible to science, and it's not a problem. That's the whole part that I was talking about with literature and the arts and culture, this catharsis that we might that we might find in different enterprises other than science. But the part about the Big Bang and simultaneity, I'm not sure I got that.
Meaning that everything has, like, if the universe, so if everything is simultaneous, maybe at a universe level, everything is already is. So how can we talk about a universe that is maybe expanding, or a universe that all of a sudden experienced some sort of Big Bang, if it already is? I don't know. I'm trying to understand.
No. I do understand. The experience part, we already talked about it, because that's a completely different thing. But if you're saying that relativity tells me that everything is, then cosmology tells me that the universe is expanding, we do have a paradox here, and that's the problem. Is that different theories are interested in different things. So the philosophical, the metaphysics of relativity are exactly the opposite of the metaphysics of quantum theory and of cosmology, because in cosmology we do suppose there is some kind of what we call cosmic time relative to which we measure expansion. So yeah, I understand your problem, because if relativity tells me this about reality, cosmology tells me something else, and quantum theory tells me something else too, because the concept of time in quantum theory, at first, it was quite Newtonian. So yeah, whenever you put yourself in one theory, you get different metaphysical or ontological baggage. And this is why physicists today are working on what we call a quantum theory of gravity, because they think that they want to unify all physical theories into one. Some people used to call it the theory of everything. That's worse than the God particle, because we're not looking for a theory of. It wouldn't be a theory of human consciousness. It wouldn't be a theory of music. No, it's not a theory of everything, not at all. This is also to sell books. It's a theory of. It's a unification of all physical theories that we have today, and I think it's been 60 years that physicists are working on this, and we don't have a lot of advancements. And I think Feyerabend would agree that this is due to the fact that when physics was developing in the 50s, it was too technological, because we had discovered the laser and everything it can do with computers, etc. We actually maybe needed physicists who did not care about history and philosophy, because you needed the school of shut up and calculate, the school of Merman and Feynman, who was very, very disdainful of philosophy, even if his writings are quite philosophical in themselves. But you needed these kinds of physicists that think in physics you should shut up and calculate, just make something useful out of everything you have. So maybe this philosophy worked in the 50s, but I think today, if you're searching for some kind of theory of all the scientific theories, since you can't but take the metaphysical baggage into consideration, we're going to have more philosophically inclined physicists. That's what I think.
Interesting. And we can maybe talk about, not talk about, in general, we about several layers or levels of reality.
Yeah, of course.
Maybe related to Madonna's question on the concept of the instant or the now. What would it mean for an observer to conceive of every instant in the present as the end? Do you think that would free the conception of time from an orderly continuum and grant it a more generic potentiality instead? I'm curious to know what you think. If you want to read it, should I repeat it?
Yeah, could you? Because I know there's a problem with the now, but
let me find. So, on the concept of the instant or the now, what would it mean for an observer to conceive of every instant in the present as the end? It's like we go back all the way to what does it mean to? I don't think it's a conception or perceiving the end. How do you think the end? If I'm
there are many ends in physics, because in cosmology we're interested in guessing how the end of the universe is going to look like, and in relativity, the thing I was talking about at the beginning about the eternalism thing, there's no beginning, there's no end, there just is everything that possibly could happen and everything that maybe already happened. But in cosmology, I only talked about scientific cosmogony by saying that Lemaitre was interested in how science can eliminate the idea of creation. But today in cosmology, we have what we can call a scientific eschatology, because there are actually cosmologists who think that they can empirically determine the ultimate fate of the universe. Is it going to become some kind of cold symmetry of energy? Is it going to be reclose on itself? So the question of end is also present in the philosophical discourse about physics. I'm going to reread the question, maybe.
Yes, on the this one on the concept of the instant, and then Romans. Can you see it?
Yes. Yes, yes. I tend not to take eternalism. That's one of the most. That's one of the things I'm interested the most in. Scientifically, I tend to think that eternalism is true, because relativity seems to entail this. But I don't want to. I'd rather live not believing in it, because if you take it very seriously, it would reduce the any talk about potentiality big time. Yes, because if you mean by any moment as being the end, because you would have less and less control about everything that would happen. And this is why I started with that, because it's very rare to find something very metaphysical in science to have such moral implications for us. Because if you believe in eternalism, you actually have a thing or two to say about free will and freedom. So I'd rather not go there and just think about these things for fun and not take them too seriously in my day-to-day life. Yeah, and that's a lot of physicists did that. That's what Carnap meant when he said that Einstein had a problem with the concept of now, because his science was something and his manifest image was something else. And he always chose the latter. He was very humanistic, etc.
So I think
yes. The question that I'm reading there, yeah, we can say this. If we want to believe in eternalism, we would have to rid ourselves of the concept of simultaneous, because it presupposes some kind of passing of time. But yes, all of them are simultaneous in the sense that if you were able to have a God's eye view everything there is, you would find that everything is. I'm not even saying it already is, because I'm ridding myself of any temporal use of language.
Yeah, it's it isn't this like it. What surprises me the most is that maybe it's a problem of language, maybe it's a problem of belief, maybe it's a problem of not wanting to, or waiting until you have perhaps sufficient evidence, which we might not. And this
that's something
question
we should talk about.
seem a bit naive, the question, but I mean, how is this any different from religious conceptions of God? Not in the personified God that, you know, with the all-knowing, it, or like not the monotheistic God. It's just when they talk about this absolute, or that this thing that already knows the future and the past, it's kind of similar.
It is. And the first part of your question is even more important, because there is a problem with language. Of course there is, especially in metaphysics, because that's what Wittgenstein was all about. Because and I really agree with him on this point, that he thought that a lot of metaphysical problems are just our way of abusing language. And by abusing language and saying that in the beginning there was nothing, we are automatically giving some kind of existence to the idea of nothing, and going through all these metaphysical corridors and debates that are actually meaningless. And this is why a lot of logicians, I know you don't agree with them, but the way they started the beginning of their program was actually very moral. They wanted to clean language out of all these metaphysical misconceptions. And to answer the second question, yeah, it's not very far. Laplace, who was a staunch materialist, he conceived of what he called what we call today Laplace's demon, this all-knowing entity that, in virtue of it knowing all the initial conditions of the universe, and in virtue of it knowing Newton's laws, because we had Newton's laws back then, he would be able to know every possible state of the universe there is. Descartes' demon. We always have these weird demons, Maxwell demons. I don't know why there are so many demons in the history of thought, but they are hidden conceptions of what you might call any kind of God that you might see in a theological discourse. Yeah,
like what's their problem then with these modern, like the initial? This is the thing with every new kind of field, or people who genuinely are trying to clean it up from all sorts of gibberish and misconceptions. It eventually turns into just a more specialized field that becomes all too abstract. So in this case, why this insistence on, and it's not a monotheism, or it's not a God apology here. It's not an apologetics of God, but why the hate? If materialism it turns out not to be what we think about as material.
It is, exactly.
And if it's like, and then the past and the future, whatever
I
that
totally
means,
agree.
are already there. And then why this hate towards, I don't know. It's like thinking about the fact that maybe the universe was designed. Is it only that?
Wait. That's what I had in the thing, that the fine-tuning thing, because there are even some cosmologists that think that the universe is finely tuned, because there are a lot of physical constants that have weird values that would alter completely the way things are if they were not what they are. But this is the problem with what I called in the beginning, or you called, new atheism, because, and this is why I don't talk about this. I really don't talk, not in any lecture I might give, but when you want to think about the relationship, or about the similarities or the differences between these two things, automatically you would get into what you just called, why all the hate. And atheism, intellectual atheism, is not what it used to be. It's not what it used to be. If you read the Hume, if you read Einstein's letters about all the questions revolving around God, but the problem is that you have hate on both sides. The scientific worldview wants to prove that religion is dumb because you know science, and that's very, very wrong, and it's intellectually empty. But on the other side, you would have all these extreme creationist discourses telling you that, yeah, the Big Bang proves that God exists. You see, so you have to find common ground. But if you look closely, there are heavyweights, philosophers or scientists, etc., on both sides. They're very rare today because they are clouded by the hype and the new atheism and things that sell. You'd read a book saying that Darwin's theory proves that God doesn't exist, quantum theory proves that God doesn't exist, or that it exists, because it can go both ways. But that's not the kind of discourses that we want today. We have to think about how to maintain a religious or non-religious worldview with everything that is going on in science. But that's not the way to do it, because when you do it, either you're making the other thing ridiculous and attacking it on both sides, and either way you're going to be wrong. But I don't know, and that's what's missing today. That's what's missing. We want discourses like Galileo's discourses about, because fundamentally they were about the church with all its power against the new science. We need discourses like Hume's natural discourse on natural religion, but they don't make them like that anymore.
Yeah, which is unfortunate. Yeah,
it really is. Yeah.
And again, it's not about the actual, so the
of course,
your typical monotheistic. It's just the concept itself, and the concepts they're dealing with. They might have changed in content, perhaps, but then formally we're still, as Suhaid is saying. I understand the first reading of the ancient philosophy better. It's interesting. And it's interesting that in Arabic language, we do recognize different layers of the eternal / endless. So it's conceptually, the concepts are there. It's just our understanding of the world
incommensurable. Yeah, exactly. Yeah. Because just like she said that, because that's very interesting how different languages have different metaphysics. And it's a very well known, a lot of people work on this. And physics, mathematics is another language that has its own metaphysics. So let's not put the two together and say, okay, this one is better, that one is better, because we have to put them all on the same level before trying to have a clean discourse about the relationship between any creationist metaphysics and scientifically informed metaphysics. That's a very, very tough one.
Yeah. And in this case, what would the first principle be now? Like, if we are going to be adopting
a pre-Socratic
approach, what's the arche now?
The arche,
energy.
That I don't know. In the late 20th century, they would say yes. What I would say, and what I think most physicists, theorists would agree on, is field. Field is the new arche. Yes, because all physical theories mathematically are field theories, and we have tendency to think that the most fundamental entity there is at least describable in field terms. So yeah,
Plato was right when he called it receptacle.
I don't. Again, I think we can't make physics vindicate some old idea, because I'm sure
definitely,
the way Plato intended it. Yeah. I know exactly. Just like atomism, but yes, in quantum theory, for example, you have this idea that what you call an electron, a particle, is only an excitation that is very localized of something that is all existing. Just like the Higgs boson, the Higgs field, you can say it's Plato's receptacle. You can do that, of course. But since I'm very careful in my readings of the ancients, that I don't like talking about atomism today and a long time ago. That's hard to.
Otherwise, we'll end up with a Marxist reading of Democritus and Epicurus. قصدا
it had it
قصده ايه ازلي وابدي وسرمدي. Yeah. something which is, I think it has a start, but then it's eternal. This Jamal is saying this is maybe the only public physics lecture where the speaker isn't trying to convert me to some cult.
Thank you. Thank you so much. But by saying that, I think I'm gonna at least think to myself that I was able to do what I wanted to do in the first place. And again, I'm no reference neither in physics. Some would say I'm a failed physicist exiled to philosophy of science, which I also do very, very badly. But physics is not supposed to be this converting enterprise, neither towards atheism nor towards theism nor creationism. Just do it. It's really fun. Maybe someone here is actually a physicist or a physicist.
Jamal is. He graduated recently. He has a.
That's great. Yeah. So if I can, let myself just give you a piece of advice that I think you already know, is that it's cool. It's fun. If you like doing the mathematics, just it's fun. I don't want to vindicate atheism or theism or creationism. I think physics is interesting. It gives results. It's fun to do. I think about it as an activity, just like music, just like everything else I do. Let's not take things too seriously. Yeah, thank you all for your messages.
Ended up with let's not take things too seriously. Sardonically speaking, we have to
that's your motto.
sardonic attitude. Exactly. Thank you very much. I don't know if anyone has anything to say, but I really enjoyed the talk.
Thank you. Thanks again. We'll do it again soon. I promise you in front of everyone that I'm going to become more active on Twitter and eventually get half as good as you are with your online courses. I will do that someday.
I'm trying to encourage.
Yes. Yeah. I will, Jamal. Thank you. I'm there, but I'm not active. Let's say I'm going to start tomorrow, since I have all you beautiful people as my friends. So this way we can get Mahmoud to do this kind of gathering sometime soon, or maybe have a course on relativity or quantum theory, the way it's intended to be thought.
Yeah, and more discussions like that, because they are, to be honest, much needed to clear things up.
Exactly. Yeah. With everything that is going on, of course. Yes.
So I'll